So we're given the tangency or the optimal portfolio from part A, and we're asking, given a particular risk level, what's the optimal allocation combining that risky asset and the risk-free asset. So on a diagram, it looks like the optimal one from before and the risk-free one, and this is the tangency portfolio, and we want a particular level, say 0.2 level of risk. This is risk, this is return. Then we are asking what this is. So this is basically some proportion of risk-free and other some proportion of risky, the optimal risky that we found in part A. So we just want to find that proportion. So suppose we are investing Y in the optimal and 1 minus Y in risk-free, then we can actually compute this. So the return of this portfolio is again just risky is this. This number is from part A times Y plus the risk-free asset. What's the risk-free? 0.07 times 1 minus Y, and sigma p squared is the same thing, just the risk of this risky asset plus the risk of the risk-free asset, which is 0, and 2 times the covariance is 0 as well, so we don't need all of that. And for this person, we want to maximize by choosing Y, his utility function. His utility function involves something called the risk aversion, so this is just Rp minus A over 2 sigma p squared. So now you can substitute these two expressions here. But we want a particular risk level, so there's a constraint. Subject to the constraint that the risk is 0.2. So one thing that can simplify this maximization is that this constraint directly you can solve for Y. So 0.2 is basically this thing squared is 116 squared Y squared, which means Y is equal to, I need to take a look at the numbers. It's 1.724. So we solved Y already. So then we don't actually need this equation. So we only need the first order condition to get the relationship between Y star and A. So fortunately, we don't need that as well because you have formulas. So again, use formula, you can get the A, which is just Rp minus Rf divided by sigma p squared times Y star. So you have the Y star already, substitute this Y star here, and you have all the other numbers. You can get them by substituting the Y star as well. So that will result in 2.21.